Okay, let me try to make a real quick video on something I think I should have covered. When you have a number like 2, let me move this over a little. You have a number like 2. Let's say it's implied that this number has a 1 under it. Also in front of it, it has a 1, and it can have a direction of either plus or minus, and also it's assumed to have a number 1 for the exponent, and of course that can have a sign on it as well, plus or minus. It could be positive or it could be negative. For every number. And what we do is include these numbers whenever we need them. If we don't need them, we ignore it because it's 1. So we're only interested in this number primarily, right? So let's say I have something like 2 plus 2. Well, that's 2 numbers being summed together, right? And so I can represent it as there's 2 2's, right? There's 2 2's. But these numbers still have 1 right here. They still have a 1 there. So I can say there's 2 of these. 2 of these. Well, if I have 3 of them, would be it's just 2. That's all it is. So now I have 3 2's. Well, what if I didn't specify what this number was? And I just said, well, 2 to the x is equal to, let's say, 2 to the third. That means x, in order for there to be equality and balance, x must be what? 3. It has to be 3. So x, in this case, is equal to 3. Right? So if I gave you a problem where I said 2 to the x plus 2 to the x is equal to 2 to the 4th. There has to be equality. Whatever's on this side, because everything evaluates to a number. Just because you have x's here, that don't mean nothing. These eventually become a number. We just don't know what it is right now. So this side becomes a number, even though this is an expression, and it must equal whatever this number is, right? So this, from what I've just shown, can be written as 2 of these, correct, is equal to 2 to the 4th, right? There's 2 of these. These are being added. There's 2 of them. 2 of them, right? Now, what does this number up here represent? What does this represent? This exponent. This exponent is saying that there is 2 times 2 times 2 times 2. If it was 2 times 3, then it would be 3 of these. If it's 2 times 5, it would be 5. This just tells you how many times this base is being multiplied. Not added. Not added. This number tells you how many is being added, and this number tells you how many are being multiplied. Right? So 2 to the 1, 2 to the 1, 2 to the 1, which is just 2. Right? That's why you add all of these up. 1 plus 1 plus 1 plus 1 is 4. 1, 2, 3, 4. Right? This is equal to the sum of all those numbers. Which is just 4. So I can solve this by doing something like this. 2 to the power of x is equal to 2 to the third. Take 1 off, right? I take one of them off. So 1, 2, 3. That'd be 2 to the third, right? Just 3 of these instead of 4. Times 2 to the 1. And now, if I divide both sides by 2, because whatever you do to this side, you must do to this side. So I divide this side by 2 to the 1, or 2, and I would divide this side by 2 to the 1, or just 2. These will cancel out, right? And all I'm left with then is, all I'm left with is 2 to the x is equal to 2 to the third. So, once again, in order for there to be a balance, x must be what? X must be equal to 3. Just thought I'd let you know and give you something to think about.